So we have options for incorporating our rope rescue systems into aerial ladders. There are probably more options, but the four kind of most common ones, at least that I've talked with people about, are these four scenarios. Nothing's off the table, but some work better than others. And there is no one configuration that's going to give you all the benefits and no downsides. And a big thing to consider really right out the gate is like, how much is your load? We want to minimize the amount of load. So we want to try and keep one person suspended. Sometimes that's not possible. Sometimes we may have to do like a pickoff, and we might need a rescuer on the line as well as another person. So two, really, like worst case, we're gonna have two people as the load. So let's look at option one up here. Okay, we terminate a line and we hang it down and the load's suspended and there's no other devices. It's basically a hard tie off to the tip. So our resultant is the load is 100% always straight down. Most aerials can probably handle that at the tip, regardless of the extension and regardless of the angle from horizontal all the way up to vertical. The downside to this is you're actually going to be using the hydraulic element. So this is not going to be locked out, tagged out. So that could be a con, but the counter pro to that is that it's a fixed line so that any movement here is not going to affect any further lines that need to pass through like pulleys or devices. So there's no interference there. Then you could kind of argue about the OSHA requirements. Downside to this is, well, you kind of need to get this rope length right. Once you have the rope length set, you're not going to change it. There's no real adjustability here. An option. Let's look at another option. Okay, well, you put a device here that can definitely lower. It might be a stretch to try to put a haul system in here, and you have a person on the tip operating it. So the problem with this is that you're automatically, like if you have a single person load, you're doubling it unnecessarily. You're putting another person, just a mass on the tip. If you have a two-person load, now you have three, really you have three people. It's a three-person load. I don't know if I've ever seen this done before, but right out the gate, I kind of don't like, I don't want that option. This represents your pre-rigged block and tackle, your 4-to-1 with a final change of direction, or peg rigs, as some people like to call them, where they have the progress capture somewhere up here and then the input down here. This option, it does a fairly good job of keeping the resultant load, the force amplification on the anchor. Yeah, it's greater than 100%, but it's pretty low, it's 125%. The downside to this is that you eat up a lot of rope. And depending on the height, it could be undesirable. And then I won't even go into confined space applications where if this is going down a hole, like how much actual material you're putting into that space. Also, trying to operate this, really, you can only really operate this like straight down from the ground. And hopefully you have a long enough pull cord here to release the capture. So it can be problematic in that respect. You have to have somebody like at least close by underneath this to be able to operate this system. But the downside that I don't like is even though it's 125%, which isn't that much, it kind of pigeonholes people into thinking that like, yeah, okay, like you put a two-person load on this, like have a shallow angle, your resultant is straight down, and that creates this huge torque effect right here, like a huge lever. So I'm not a fan of doing that. Not to say it's off the table, you can certainly do that. You just have to make sure that you watch this angle. You know, the steeper the angle, the more this resultant goes in line with your stick. And we'll talk about the theories behind that and different schools of thought. This system doesn't quite facilitate a two-tension rope system as easily as this one. This one's just a simple change of direction, using the aerial high point as a high directional. Okay, the major downside to this right out the gate is depending on the angle. I'm just gonna say right out the bat, anywhere between 180 or 1.8 to 200% or 2 times force amplification on that tip. So if you put a two-person load here, worst case, we say 450 pounds or 2 kilonewtons, and then you amplify that double to 900 pounds or 4 kN. At the tip. Again, the same thing with a flat angle doing this, you got to be really careful because your resultant, while it isn't straight down and it doesn't create as much of a torque lever effect down here, it's still, I don't know if it's sixes because you still have a greater force amplification even though the resultant is closer in line. I don't know if it might be just sixes between doing these two at a shallow angle. Where this shines is our ability to reach and not have any operators down below. So anywhere we don't have access, like over a bridge, like trying to like rescue somebody who's in the water over a bridge or below grade or in a vehicle that's hanging off the side, you're not gonna be able to do a pig rig in that regard. If you combine just a simple line as a high directional with a steep angle, like at least 60 degrees probably, at least on our aerial, our load charts say that the capacity goes from 500 pounds at the tip all the way up to 1,000 when we increase that angle, regardless of the extension or regardless of the length. So in that regard, it makes me think that the engineers were probably thinking that this was stronger when the resultant was closer in line with the stick, and the weak point is not the hydraulic elements between the flies that are keeping it extended. So this is ours, it's rated at 1,000 pounds at full extension once you cross over 60 degrees. And then incrementally it drops off the flatter you get. So those are some considerations. This high directional here with a line, you can more readily and easily do a 2-tension rope system configuration. Plus, we're big fans of joining our lines at the terminal end with a double long tail or interlocking long tail bow line, and this system facilitates that much better than this would. So it's just a personal preference that I like doing this. But in all cases, I need to be wary of a couple of factors. So if this is my aerial ladder stick, and I need to be cognizant of the length as well as the angle relative to the horizon, and how that changes my resultants and what my load is. Again, like the longer the lever, the longer the length, if you just had like a resultant going straight down, that increases the torque at the fulcrum down here, which is bad. So shorter the length, the better if you're going to operate a resultant force straight down like you would that 4-to-1 block and tackle. Not as much of an issue with our aerial because our load charts say at full extension, like as we get higher, our resultant shifts into the stick and we can have a greater load capacity at the tip. Yeah, I always want to consider keeping this angle steep, and then the length of the lever is secondary to the priority being the steepness. One more negative about this is the bounce effect. So the Hall effect, this tends to be more of a jerky haul, and you tend to oscillate and bounce and spike your forces here at the tip. Whereas here, having single line or 2-tension line through the high point and then having an additional directional close to the fulcrum, to the outrigger, to an anchor point, anywhere, I can dictate where this is now, and I can put in haulers and adjust my haul field and my throw, and I can have a smoother raise operation that's going to ease like the oscillating bouncy forces that the tip would have to see. I can even put in a winch down here that would make it even smoother, whereas I can't really do that as easily here. Cantilever truss-like versus crane-like, I don't know. I am more favoring crane-like, the spirit of crane physics over a cantilever truss. Cantilever truss favors the idea that it's better to just load this straight down at the tip, whereas crane-like rigging favors keeping the resultant as close to the stick as possible to maximize strength and reduce the torque effect here. And granted, an aerial ladder is not a crane, but if we do lockout tagout and we rig a rope system into it, we can adapt crane physics and treat it kind of like a crane with those resultant forces in mind. On our aerial, since our load capacity basically doubles once we get from like the 30-degree range to beyond 60 in steepness, regardless, and that's at full extension, so regardless of the ladder extension, we double our capacity. So that goes hand in hand in concert with crane physics, loading your forces along the stick, as opposed to like thinking that it's designed to be cantilevered. I don't think it really is. You can do either or, you just have to know what you're doing. So let's go over to how any mechanical advantage system that has a final change of direction, what effect does that have on the force amplification on your high point, your anchor point? Let's take a look at this. So it says force amplification for an anchor with a final change of direction is going to be basically 100% or 1 times, so 100% of the load, plus the inverse of the mechanical advantage. Okay, is that a spoonful and a lot of words? Yeah, so let's do it visually. Okay, this represents our classic just one-to-one change of direction, and so we have the load at 100%. I have to pull 100% because T in, T out, you do the T method right, it's the same, like the tension is the same, and we're disregarding friction here. One in, one out. So the force on that is 1 and 1. So it's always 100% or 1 plus the inverse of what the MA is, which is 1-to-1. Inverse of 1-to-1 is 1. 1 plus 1, 2. That's 2 times the force of the load, or 200%. Okay, let's go to a 2-to-1. Let's go a little bit faster here. So we have 100% of the load, 50-50 split on the strands, but the tension on those 50% strands is going through a directional, and I have to hold whatever tension is here, here. So it's 50-50-50. Now, even not looking at this, I say, okay, that's a 2-to-1 with a final change of direction. I take 100% of the load plus the inverse of 2-to-1, which is a half. So 100% or 1 plus half is 1.5 times the load, or 150%. Let's go even faster. 3-to-1. 100% plus a third is 1.3x, or 130% amplification. This represents our high point, our classic change of direction, or high point, and this one represents our block and tackle, our 4-to-1 peg rig. So let's look at that. 100% of the load is here. We split up all the strands. I don't really care here. I just say 100% of the load plus 1/4, which is the inverse of my 4-to-1. Gives me 125% amplification, and so on and so forth. We go 5-to-1, it's less. It's never going to be less than 100%, but the more mechanical advantage you have, the less force you see on your tip. It's just an easy way to figure it out. Simulating a truck over a bridge where it's a ways out. We can't get anybody out there, so we're gonna have to go up and down vertically as well as left and right. Probably incorporate some sort of offset system. Below grade, team-based, unsupported pickoff with an aerial over a bridge, but it can be applied anywhere. Trench, confined space, some other aspect or some other scenario or environment. 2-rope system. We're gonna try and stick with 2 ropes because it's all we carry on our ladders, 2 300-footers. We're gonna do a single line going through the very high point of the aerial. That's our critical point. We're not gonna send another line through to act as a belay because we're gonna be fairly confident that all our rigging for that main line and the operation, it's pretty much bomb-proof. We're gonna accept the risk on that critical point on the aerial, but we are gonna have a second line that's gonna act as a quasi-belay, and that line is gonna route through kind of one of the directionals. And that line is also gonna double as a vector line, because if you look at the bar here, the railing over the bridge, as we bring a package back in and send a package out, we don't want to be operating this line up like this because we're gonna stretch that main line and kind of create higher tension forces, kind of like a mini high line. We'd rather have our belay line, vector line elevated, so when we pull it in, it acts more like this kind of like a little cross haul. Interlocking long tail bow lines for this application, because one is the belay slash vector line is dual purpose, so it's kind of like we're doing an offset system within the aerial to keep these angles in check, but to prevent the weakening of a double long tail bow line on the knot by pulling itself apart. And now I can have this angle and this can be pulling this direction without weakening the knot. So interlocking long tail bow lines. Our rescuer is on an adjustable set of force or some sort of adjustable system. There's no guarantee that he's going to use it, but it's an option if in case he needs to, and it could be beneficial. It's better to have this in here than not. Standard prusik belay on the long tail to the sternal as his backup. We're doing this below grade, and so depending on where the subject or victim is, if they're like in a precarious spot, like a precarious vehicle hanging off the side of a bridge, we want some sort of adjustability in the patient system. And so we're just going to put in a Purcell prusik here because we don't want the rescuer to actually go into a vehicle. Our rope system isn't going to go down in there. We're going to stop before that happens, and then Gabe can adjust himself, and we can also adjust the seat harness that we're going to put our victim in on the Purcell, so Gabe can extend this if needed and instruct our patient to put it on. There are some nuances with this CMC patient harness system and the chest kind of cradling adapter. It's not as clear cut and dry as you'd think, because you do have the ability to quite easily put this on and rig it on your patient in a bad way, meaning that you can potentially just have the chest sling loaded 100% and nothing else. The harness doesn't do anything. I like to break down this kind of harness system into 3 components. So the first is the adjustable primary purcell with the seat harness. That's component 1 as far as a functions perspective. The next component is going to be the extender. So from the pelvic ring to something higher. So this piece is the extender with that connection. That's the second component. And then the third component is the chest sling itself. We're going to systematically try to figure out the best way to actually put this on our patient so that we don't inadvertently just load them completely on this chest sling. Ideally, he'd want to keep this purcell as short as possible and only use it if he does in fact have to extend it down to me. If Gabe is able to have me crawl up a little bit and he can adjust and choke up on this purcell to get it back to where it needs to be, great. This is what we want to do every time. We want to try to get this thing back up so that it's as short as it's going to be. Okay, that's step 1. Step 2 is going to be this extender. I want to be loaded on this and not on the purcell, because that's going to actually help with how comfortable this thing feels when we incorporate the chest support sling. So step 2 is choke up as far as you can on the extender, which is attached to kind of like a similar case. It's on the backup. It's kind of like a backup on that other long tail, the double long tail ball line. And we're going to stretch this up as far as we can go. If we can get all the way up to the yoke, that's great. And now I want to load this primarily and ease off on the purcell. So we're going to go down on the purcell until it's completely slack. So we know that we're loaded on this extender right here. So this is my primary loaded point, even though it's on the back up of the long tail bone line. I don't really care because I'm on 2 points, it's fine. The last step is to put the sling on. So I want this to be off and out of the picture until the very end, after I have made these connections in that order. So chest sling goes on, I keep it loose, and I can do this, or the rest of you can do this. So right now, I can just flop over, and then myself or Gabe can start to pull in and get myself high, and I can adjust this while we're actually flying on the move. And I can adjust where I want my torso to sit in relation to that. So I can choke up, and this cradles me. Granted, there's some support here, but it's still primarily loaded here. If I didn't do it in that sequence, and I was primarily loaded on my chest sling first, I would be 100% on this sling into the system, and my seat harness could potentially do nothing for me, and this is very uncomfortable, it's painful. So primary connection, interlocking long tail bow lines through both, right there. Okay, backup, standard, sternal, cross-leg. Okay, am I in plumb line? I am. Okay, hand taut on yellow and blue. Taut on blue. Okay, hand taut yellow. And you just want to hand me the patient harness around real quick. Primary connection. Also through both points on the interlocking long tail bow line. Right in here. So we're both in there. And get this tail out of the way. Okay, full friction on blue. Full friction on blue. Waiting on blue. Okay, waiting the system. Okay, out on blue. Out on blue. yellow line.
Yellow.
Get the waist on you first.
Copy that.
No.
Oh,
Leave that on. There we go. You putting it on?
All right.
Get that thing as tight as you can. Do a couple squats and get those leg straps as high up in there as you can. Change over.
Okay, all right.
Good.
Any more? Good.
Okay. Now let's suck you up. So come towards me more.
Yep.
Give me a quick hop. There we go. A little more. Okay. We're set there. More. Keep going. Keep going. Keep going. Okay, it's fully slacked, fully weighted on this.
Yep.
Okay. Let's go ahead and put this chest component on.
All right.
Okay. Go ahead and attach yourself right here. Okay, not too much.
That's a little bit, right?
We're gonna adjust once we're gonna keep this a little bit loose until we're full suspended, and then we can adjust, and you can adjust that yourself.
Copy.
Okay, feel good?
Feel good.
Okay. Ready?
Stopping.
Now in on vector line.
So as we start to haul cap, it's going to get hard for us. So you may need to let him down a little bit.
Yeah, I'm figuring we're gonna have to let him down to swing him in, right?
Yeah. In on blue.
We're going to get a shot at this angle. 45. Well, we want to maintain like a tight angle here as best we can. Okay. And Cap, if you can try to keep the yellow so that Gabe's feet are just hovering above the railing.
Out on yellow, and we're going to float Bob right here. So just keep the
Do that. And then when we land, just the final angle as that comes under. Okay, we start to go down on yellow. There we go. It's a good angle. You can't do that with a double long tail bowline because it'll split the knot apart. But your interlocking long tail bowline, you can load it that way. Okay. On the ground, slack.
On the ground, slack.
Slack on blue.
Okay, court.